Today we are going to solve indefinite integration by the method of substitution. Usually we cannot integrate all the functions just using fundamental formulas. So we have to change the variable and transfer the integration into a standard form, then we can put the formulas and get the answer. Let integration fx dx, taking suppose x is equal to phi z, so dx dz equal to phi dash z by differentiation. Dx dz is phi dash z. Dx dz equal to phi dash z, or dx equal to phi dash z into dx. Phi dash z into dx. Now if I is equal to integration fx dx, then di dx is equal to only fx, because integration and differentiation is the reverse process. If we differentiate a function, then integrate it, it becomes the original function. Okay, it becomes the original function. Now di dz equal to, we can write by chain rule, di dx and dx dz, di dx into dx dz. So di dx is fx, di dx is fx, and dx dz is phi dash z, dx dz is phi dash z. Then from definition, I is equal to integration fx into phi dash x, phi z dz, and this x can be replaced, phi z. This is the process. We are taking this into a standard form. Now we can integrate it. Okay, so we are going to write some formulas again. We, in the previous episode, my first episode, we are given all the formulas of integral calculus, but now we are again giving some formulas that is used in method of substitution. Integration tan x dx is log of sec x plus c. Integration cot x dx is log of sin x plus c. Integration sec x dx log sec x plus tan x plus c. Integration cosec x dx is log tan x by 2 plus c. Integration dx by x square plus a square is 1 by a tan inverse x by a plus c. Next, integration dx by x square minus a square is 1 by 2a log x minus a by x plus a plus constant. Integration dx by a square minus x square is 1 by 2a log a plus x by a minus x plus constant integration dx by root over x square plus a square is log x plus root over x square plus minus a square plus c, and last integration dx by root over a square minus x square is sine inverse x by a plus c. So now we are going to start some problems. This is method of substitution of integration. Now my first problem is integration e to the power x into 1 plus x by cot x e to the power x. Now we have to put in such a way that we can derive the integration into standard form. Now putting z is equal to x e to the power x. You can put 2t also, or y also, anything you can put except x. Since the problem is in with x, so we can put without x any value, z, t, anything. Now if we differentiate, dz is equal to x into e to the power x, it is u into v form, ddx of u into v form. That formula is v ddx of u plus u ddx of v. This is the multiplication formula for differentiation. So if we consider u, this is v. Now differentiation of x is 1 e to the power x, then x into differentiation of e to the power x dx. This is u into v rule. Differentiation of x is 1 e to the power x as it is, then plus x as it is, and differentiation of e to the power x is e to the power x. Taking e to the power x common, 1 plus x dx. So dz is equal to this. Now we can write in place of this, now we can write in place of this just e to the power just dz, because e to the power x into 1 plus x dx is equal to dz. Now here we replace that whole thing to dz, and this is cot, this is taken as z, cot z. So now 1 by cot is tan z. Integration of tan z is log of sec z plus integration constant. This becomes into standard form. Cot tan z dz, it is become into standard form. Now we can integrate. Integrate of tan z is log sec z. Now putting the values of z, sec x e to the power x, because z is equal to x e to the power x plus c. This is your answer. So we repeat, we put z equal to x e to the power x. Now we differentiate x e to the power x as a u into v function of differentiation. First we differentiate x and e to the power x as it is, then plus x as it is, and differentiation of e to the power x is also e to the power x. Now taking common e to the power x into 1 plus x dx. So we become dz equal to e to the power x into 1 plus x dx. Now we substitute this value in this. E to the power x 1 plus x dx is dz, and cot x e to the power x is z. Now cot z is equal to tan z dz, and we become into the standard form of integration. Now integrate log sec z plus c and putting the values. This is our first problem. Now we are going to second problem. Now we are going to second problem. Problem number 2, x plus cot x whole square into cot square x into cot square x dx. Now here we put z equal to x plus cot x. Here we put z equal to x plus cot x. Now differentiate both sides. Dz is equal to differentiation of 1 x is 1 and cot x is minus cosec square x dx, minus common cosec square x minus 1 dx. So cosec square x minus 1 is cot square x. This is 9-10 formula of trigonometry. 1 plus cot square x equal to cosec square x. This is the formula. So we can write minus dz equal to cot square x dx. Now we substitute this cot square x dx by minus dz. Cot square x dx is minus dz, and we have putting x plus cot x is z. So this is z square. X plus cot x whole square, that is z square, and this cot square x dx we can write minus dz. Now minus z square dz. Now integrate, it becomes into the standard form x to the power n formula, that is x to the power n plus 1 by n plus 1 plus constant, that is minus z to the power 3 by 3 plus c. Now substitute the value of z, x plus cot x whole cube divided by 3 plus constant. This is your answer. Simple problem. We have to put in such a way that it becomes a standard form. Then we can integrate by the formula using written before. So putting is the essential part here. Now we are going to third problem. This is the most, I think this is the most intelligent part of integration. Next we are going to solve another problem. Dx, integration dx by e to the power x plus e to the power minus x whole square. Dx by e to the power x into e to the power minus x whole square. Now simplifying first, e to the power x plus 1 by e to the power x whole square. It becomes e to the power x into e to the power x, e to the power 2x plus 1 whole square divided by e to the power 2x, because e to the power x whole square, that is e to the power 2x. Now this becomes numerator, e to the power 2x dx by e to the power 2x plus 1 whole square. Now we put e to the power x, putting z equal to e to the power 2x plus 1. So differentiating both sides, dz is equal to e to the power 2x, differentiation of e to the power 2x, e to the power 2x into 2, and differentiation of 1 is 0. ddx of e to the power mx is m e to the power mx. By this formula, we have differentiate e to the power 2x is this. Now dz by 2, these two come here, equal to e to the power 2x dx. So in place of e to the power 2x dx, we can write dz by 2, dz by 2, dz by 2, and this is z, so z square. So it becomes half z to the power minus 2 dz, z to the power minus 2 dz. Now integrate it, it becomes to standard formula z to the power minus 2 plus 1 by minus 2 plus 1 plus constant, that is minus half into 1 by z plus c, that is minus 1 by 2 z is e to the power 2x plus 1 plus c is your answer. Clear? Now we are going to fourth problem. I am trying to solve some different types of problem so that you can solve the other problem of the exercise of any books. We are trying to solve different type of problems such that you can try another problem of this exercise of any book of class 12 standard, only board standard actually. We are doing here only board standard, not IIT JEE. In further we can next in further edition we are coming to joint trans, but now we are going to solve only class 12 standard. Okay, class 12 standard, that is board standard integration. My next problem is cos square x dx, cos square x dx by x sin x plus cos x sin x plus cos x whole square, x sin x plus cos x sin x plus cos x whole square. Okay, x sin x plus cos x whole square. Now we have taken common sin x from here, so it becomes x plus cos x by sin x, sorry here dx. We have taken common sin x from here, so it becomes x and this becomes cos x by sin x. So cos square x dx by sin x whole square is sin square x, and this is x plus cos x by sin x is cot x whole square. Cos x by sin x is cot x. Now cos square x by sin square x is cot square x. Cos square x by sin square x is cot square x. Now we put in x plus cot x equal to z. So dz is differentiation of x is 1 and cot x is minus cosec square x. Taking minus common, cosec square x minus 1 dx, that is cot square x. Trigonometric formula, cosec square theta equal to 1 plus cot square theta, using this. So we are getting here minus dz is cot square x dx. Now substitute. Cot square x dx is minus dz. Substitute cot square x dx is minus dz. By this is considered as z square. So integration z to the power minus 2 dz. Again by using integration formula direct, it becomes minus 1 by z plus c. Z to the power minus 2 is z to the power minus 2 plus 1 by minus 2 plus 1, that is 1 by z, minus 1 by z. Now to substitute the value of z, plus c is your answer. Already 4 problems we are doing. Now we are going to solve another problem. Okay. Question number 5. Question number 5. Integration e to the power tan inverse root x by root x plus x root x dx, e to the power tan inverse root x by taking root x as common 1 plus x dx. Now putting, this is the main thing, which is what has to be put here. You have to put e to the power tan inverse x, tan inverse root x is equal to z. E to the power, putting z is equal to e to the power tan inverse root x. Okay. Z is equal to e to the power tan inverse root x. We have to put in such a way that it becomes to the standard form. This is the main thing of method of substitution. We have to put in such a way that it becomes the standard form. Now we differentiate that dz is e to the power x. Integration e to the power x is e to the power x. So it becomes integration ddx of e to the power x. ddx of e to the power x is e to the power x. So e to the power tan inverse x is e to the power tan inverse root x. Into, you have to use chain rule. Now we have to differentiate tan inverse x. Tan inverse x differentiate is 1 by 1 plus x square. ddx of tan inverse x equal to 1 by 1 plus x square. So ddx of tan inverse root x is 1 by 1 plus root x whole square. Again we have to differentiate root x. This is the chain rule. The differentiation of root x, actually root x means x to the power half. So differentiate half x to the power half minus 1. That is 1 by 2 root x. This is 1 by 2 root x. Okay. So differentiation of root x is 1 by 2 root x dx. By chain rule, you have to first differentiation e to the power tan inverse root x. Considering tan inverse root x is simply x, so e to the power x differentiation is e to the power x, e to the power tan inverse x. Now we have to differentiate tan inverse x. tan inverse x formula is 1 by 1 plus x square, that is 1 by 1 plus root x whole square. Now again we have to differentiate the root x. This is multiplied form because it is chain rule. This is the rule. dy dx equal to dy du into du dv into dv dx. This is the rule of differentiation. If u, v are the functions of x, this is the rule. So it becomes dz is equal to, 2dz equal to e to the power tan inverse root x by root x into 1 plus x dx. These two becoming here. These two becoming here. So now we put in place of in total, this thing is 2dz. Total this thing becomes 2dz. 2dz. This is e to the power tan inverse root x by root x into 1 plus root x dx is only 2dz. Just transform this value here. So integration of dz is z only. Integration dx is x only. So integration dz is z only. Now substitute the value. Z is e to the power tan inverse root x plus c is your answer. Actually, what thing I have to put so that it becomes the standard form? It is the main thing here by integration by method of substitution. Main thing what we have to put that it becomes the standard form. This is main thing here. Now we are going to the last problem of today, number 6 problem. Next class again we will do integration by method of substitution. Again we do integration by method of substitution. If you like my channel, then please subscribe and share. If you like my channel, then you must subscribe and share. Okay, now my 6th and last problem today is integration 1 minus x square divided by x square plus 1 whole square dx. This is my last problem of today. We divide both numerator and denominator by x square. Both numerator and denominator by x square. So numerator becomes 1 by x square minus x square by x square is 1. 1 by x square minus dx. X square by x square is 1. And now we have if we take x square in the bracket, this x square in the whole bracket, it becomes x to the power only x. Total we are taking into the whole bracket, so this x square become only x because x square is a x to the power 2, that is x square. Now it becomes 1 by x square minus 1. Now again separate this. X square by x is only x. X square by x is only x. And 1 by x whole square dx. Now putting z is equal to x plus 1 upon x. Now differentiate dz. Differentiation of x is 1 and 1 by x is actually x to the power minus 1. So dx of x to the power minus 1 by the formula minus 1 x to the power minus 1 minus 2 minus x to the power minus 2, that is minus 1 by x square minus 1 by x square dx, or 1 by x square minus 1 dx. That is minus dz is equal to 1 by x square minus 1 dx. Now substitute here this thing minus dz by z square. So integration of z to the power minus 2 is minus 1 by z. We have done previously. Now putting the value in place of z, x plus 1 upon x plus c, x by x square plus 1 plus c is your answer. This completes today's episode. Now we are going some another interesting problem in next episode. If you like this channel, please subscribe and share. Thank you for the day.